Hello everybody, in this question Emily takes part in 2 races. The probability that she wins the first race is 0.7. The probability she wins the second race is 0.4. Outcomes of the 2 races are independent and complete the probability tree diagram. So let's do this bit first and we'll move on to the B part. So 0.7 and then this will be 0. 0.3 and then 0.4, this will be 0.6, and then this will be once again Emily wins, so 0.4, and then this is 0.6. So this is the first part, and then they're saying work out the probability that Emily wins exactly one of the 2 races. So for her to win one of the 2 races, what I can do is, so it will be a combination of win and a not win. That's winning one race. And we have to add a not win and a win. So what that means is the answer will be that, so that would be 0.7 times 0.6 plus 0.3, so does not win is 0.3 multiplied by 0.4, and that is equal to 0.42 plus 0.12, and that is equal to 4, 5, that is equal to 0.54, and that is the answer to this bit. It's not minus, so no, I don't put this way. It's not a minus, it's an equal. So 0.54, so that's the answer. That's the answer to part B. So now we've got the other bit, which is the part C, and that is telling us that Emily is taking part in a third race, and if she wins both of the first 2 races, the probability that she will win the third race is 0.6. And if she wins exactly one of the first 2 races, the probability she will win the third race is 0.3. And now we need to work out the probability that Emily will win exactly 2 of the 3 races. So it looks to be like we need to make another probability tree, with the third race column, a third race branching out from the second race. So I thought we have the space here, they've already given us the space, so maybe we could draw it here, and a win and a not win. So if a win I would write as a W, a not win I could write as NW, just to make it simpler. So then I will write here, so I need to give myself some space. So then we have a win and a not win, and for the win I would have again a win, not win, and a win and a not win. So this is the second race, this is the first race, and then a third race. So win, not win, a win and a not win, a win and a not win, a win and a not win. Okay, so those are the races. So then we can write what is the one probability winning is 0.7 and 0.3. So I will write here 0.7, 0.3, and then for the second bit I had 0.4, 0.6, 0.4, 0.6. So I will write 0.4, 0.6, 0.4, 0.6. So I now need to put in the conditions of the third race. So she wins both races, the first two, but she will win the third. That probability is 0.6. So win, win, win. So that will be 0.6. Then not win is going to be 0.4. And then again they're saying if she wins exactly one of the two races, the probability she will win the third is 0.3. So exactly one, right? So not win, not win. She will win the third is this not win, not win, and then one winning. We don't know. And however, not win, and not win. So they are all not wins. So then they are saying, let's work this bit out. So not win, win. She wins one, that will be 0.3. Okay, so she's won one of the races. So then the probability she's going to win the third is 0.3. So then obviously she's not going to not win the third, is going to be 0.7. And then yes, so we didn't want to fill this bit in, and then we don't know this bit again similarly, because if oh sorry, we can fill it. What am I saying? I'm looking at the wrong thing. So because this is win and not win and win, so 1, so this will also be 0.3, and then this will be 0.7. So let's go through this bit again. So if there is a win and again a win, the third one is also winning, so it's 0.6. So if there's a win, win, and a not winning, that is 0.4, which is 1, 2. Okay, and then if you start off from the win and then a not win and then a win, that would be 0.3. That would be this value, isn't it? She wins exactly one of the first two races. So she's won the first one, the second one she's not won, the third one she's going to win, so that probability is 0.3. And obviously the not win is going to be 0.7. And then if you look at the final one, not win, and then a win, she's won one of the two races again, one of the first two races. So once again 0.3 and 0.7. So then we needn't worry about this bit, the last one, not win, not win. We don't need to we don't need to consider that. It's not relevant. So then what we're going to do is let's work out how will we work out the probability that Emily will win exactly 2 of the 3 races. So for that bit, how will she win exactly 2 of the 3 races? So 2 wins, that's what she needs to have. So we will have if she has this, let me write it down. Or maybe I can do this. So a win and a win, exactly 2. So if there's a win, there's going to be a second race win, and a third race is not win, 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 and a not win. Or there could be a win, a not win, and a win. Or there could be a not win, there could be a win, and a win. So we actually have found 3 ways in which this can be done, isn't it? Win exactly 2. So the first race, so if I now write it down, it's going to be clearer. So the answer is going to be exactly 2 of the 3 races. So that is possible if there is a win, and a not win, plus a win and a not win and a win, and plus it will be a not win, a win, and a win. So these are the 3 things, 3 ways that Emily can win exactly 2 of the 3 races. So then we can do win and win. So that will be 0.7 times 0.4 times 0.4, 0.7 times 0.4 times 0.4, and then plus our win. So that's again going to be 0.7 times 0.6 times 0.3, not win, so that's 0.6. Our win in the third race 0.3, and then plus we are going to have a not win. We start with a 0.3 and then it is multiplied by a win, which is 0.4, multiplied by a win, which is 0.3. So then the answer to that is multiply these individually, if I can do that. So 0.7 multiplied by 0.16, that's 0.112, plus 0.423, it's 0.126, plus 3 times 12 to 36, so 0.036. So that equals 2, 6, 6, 14, 4, and 1, and 2, 7, and 2. So 274, and that is the answer. Okay, so that is the answer to the third bit. So the answer would be, I would write 274, and here the answer is 0.54. That's it, really. This question.